Welcome to the fourth video in my series of what was supposed to be 3 videos, but that's okay. The last thing I want to talk to you about is what happens if we look at conjugates in polar form. And I'm not actually going to do any numbers here, I'm just going to do maths with some pictures. So here is the complex plane for the sake of argument, and I'm going to go with a number that is, let's say, about here. Let's say that is, let's say it's 3 plus 2i. So that distance there is 2. That distance along there is 3. And so let's call that my z. So if I'm thinking about z dash, then that's going to be 3 plus, not plus, 3 minus 2i. Now you'll notice I've drawn it down there because obviously I'm going to go 3 across, but then I'm going to go 2 down this time. And what we notice is the symmetry that is coming from the very definition of what a complex number is. Now even if it's that first part is the real part is negative, then I'm still going to get that reflection idea coming in there. So let's call that maybe minus 3 plus 5i and minus 3 minus 5i. Okay, but the big thing that I want you to see is if I were to draw a line here and draw a line here, then this angle in here, let's just call it theta, is actually going to be the same as this angle here, theta. Of course, if we're writing our notation in there, what's that distance here going to be? Let's actually work it out. So we've got 3 squared as 9 plus 4, so square root of 13. So if I were to write z as a in a polar form, my modulus would be 13, and then I would have cis, and I'm not even going to work out what theta is because I really want to make a point here. If I've got the conjugate, then that's also going to be the same distance from the origin, and it's going to be cis negative theta. Okay, on the diagram that's theta, obviously we would call it negative theta. Now just think for a second what's going to happen when I go z times the conjugate of z. So I'm going to go root 13, I'm going to multiply the moduluses, and I'm going to add my arguments, or those angles. We're going to add them together. Okay, that goes back to the very definition of how you multiply, how you multiply polar numbers. Okay, so when you multiply polar numbers, you multiply their magnitudes and you add their arguments. Okay, make sure you say that up. So the square root of 13 times the square root of 13 is going to be 13, and we've got cis of, that's always going to be 0, isn't it? Okay, because those are always going to be the same angle, they're always going to have opposite sides, and so when we add them, we're going to get 0. That means that whatever those two complex numbers are, could be that we might be doing this one back here, right? That angle is still the same as this angle. So when we add together, they're going to come back to 0. And that means we're always going to be on this line. So when we multiply conjugates, we will always get a positive real number. Okay? So when we multiply conjugates, we'll always get a positive real number. We knew that from expanding as a FOIL. Okay, we would get 3 times. Remember doing this way back on video 1? Okay, it's really a lot easier to see why you will always get a positive real number, I think, when you look at it in polar form. So we're going to get 9 minus 6i plus 6i. I'm not using philo, I know, I'm using FOIL. minus 4i squared. So then we got 9. Oh, cross those out, don't need those. Then that's going to be plus 4 because the I squared turns into a negative 1. And oh, look, I get 13. The same thing. Yes! Okay, I hope you enjoyed the 4th video in my 3-part series. I'm not intending on a 5th. See ya!